Welcome. My name is Linda Chen. I'm the head of business development at John Snow Lab. This talk, we will mention about the benefits and challenges in de-identifying and linking unstructured records. Mark Ungerer, head of PM at Databand, he will start off by covering Databand's tokenization and de-identification service. And I will then jump in to present John Snow Lab's Spark NLP for healthcare features for de-identification. Take it away, Mark.
Great, thank you, Linda. Very excited to be here and to talk through Databand's technology, and in particular, how we tokenize and link health records and how we're able to enable organizations to bring health data together. And also excited to hear, Linda, how John Snow Labs enables the de-identification of unstructured data, as we know that is a difficult problem and an important problem. So looking forward to that. So to jump in with the Databand 101, we'll do kind of a crash course here in what Databand is and does. So Databand's mission is to facilitate the exchange of health data and to enable organizations to get a more complete picture of the patient. And so our view of the health data industry today is that a lot of information ends up siloed. So you have medical claims, you have EHR data, you have lab data, you have mortality records, and all of this data is living in siloed organizations that can't actually be connected. So as a result, any one particular view often ends up only seeing part of the patient's journey or part of their adherence or part of their treatment. And what Databand is set out to do is to create technology that enables organizations to bring all those data together in a way that allows the linking and the complete picture to come to fruition. So that's the upshot, is that we protect patient privacy by de-identifying those records, making them HIPAA compliant, while still allowing those records to then be matched across different organizations that have worked with the technology. And then we provide tools and capabilities to share that data so that data can flow to where it needs to be to get a better understanding of the patient and their care. Now, in terms of who works with Databand, right? So this technology in connecting different data is valuable to the extent that other organizations are actually using it and that you could actually connect data with them. And so this slide gives an overview of the major types of data sources that are tokenizing, that is tokenizing and de-identifying their records and making those records available for linkage in specific use cases. So we have up at the top left here, you can see that there's 9 of the top 10 claims data sources in the US have tokenized with Databand. We work with all of the leading national payers. We work with the leading laboratories. We have a significant footprint in EHR data. We have the vast majority of mortality records and of who's deceased and when in the ecosystem and tokenized. We work with a significant number of academic medical centers. And so what you can see here is that there's a significant coverage both in terms of lives covered as well as records, years of history, and this data can be used across a number of different use cases that we'll come to in a second. So on this slide, this is the overview of who's actually in the ecosystem, and this is some of the heavy hitters and really powerhouses of medical data sources, as well as healthcare analytics and data consumers. We kind of have it broken out here by the different types of data. But this gives you a flavor for the types of organizations that are de-identifying and tokenizing their data with Databand's technology today. And we're very excited and happy to be working with this list of companies. This is a subset, maybe 1/5 or so of the overall ecosystem of organizations that are de-identifying and tokenizing with Databand today. So now we'll turn to use of de-identified data. And I think, when I think about how a lot of people approach healthcare analytics, they're often imagining a patient seeing their doctor, getting treated, the doctor's turning to their computer and their EHR and trying to pull together records to treat that particular patient. And that is a very important part of the exchange of health data and the use of data in treating patients, of course. There is also a wide and deep world of de-identified health data. And that's kind of the world where Databand's focused and where we're excited about what we're going to be doing with John Snow Lab. So to jump into some of those use cases, this slide outlines a number of use cases where de-identified health data is used to bring together different data sets and to answer questions about the healthcare and health system. So I'll highlight a couple of these really quickly. So one over here in the life sciences sector could be hybrid trial design and outcomes research, and being able to bring together different data about a patient, whether it's their lab data, their specialty pharmacy data, their claims data and diagnosis or course of treatment. That data can be brought together to help with outcomes research. You can understand patients on a particular drug and how are they progressing, what's the efficacy, by bringing together de-identified data. And it's not necessary to know who the actual patient is, it's only necessary to know that that patient was on that drug and that you're getting an accurate linkage of different data that comes together. Another related use case would be identifying undiagnosed or misdiagnosed patients, right? So if you're looking at a rare disease and you have a drug or a treatment for that rare disease, often those patients that need your medication are out there, but they're being misdiagnosed because it's not common. And so what you can do is you can bring together different data sets that might be indicators that a patient has that, understand the providers who are treating them, and provide education materials to those providers as to what are the cues to look for that this patient with this condition that just won't get better might actually be this rare disease that you have a treatment for. And that can be done on de-identified data. One more example to jump over to is academic and public health research. And so this is where different academic medical centers may contribute data to a coordinating center to allow the linkage of data, or in the case of the COVID-19 research database, which is a pro bono initiative that Databand has been a part of over the last year, we're bringing together different data sources in a de-identified tokenized context to allow researchers to perform research and ask and answer questions related to COVID-19 and different comorbidities with COVID-19, the economics around it. And so all that is done on de-identified data. So that's an overview there of what de-identified data does, and some angle into why linkage of different de-identified data sets may be helpful in answering some of the questions and solving some of the problems on this page. So now, how do we actually do it? How does record linkage actually work? We're going to give you a simple toy example here. Please don't be thrown off by Isaac Newton not being an American and probably not having a social security number. It's just a fake example here of a patient. Isaac Newton walks into the hospital. That encounter will result in a digital record. And so you can see that the hospital will record on this date, this patient showed up with these symptoms, might have had these diagnoses, was referred to these other physicians, and all that will be captured. What Databand software does is it gets installed behind the firewall. So Databand doesn't require actually seeing the data ourselves. Our software goes out to where the data is. And we'll do this tokenization. And in this case, we're saying that this patient, Isaac Newton, and the identifying information gets translated from an identifiable form into a non-identifiable form of patient 123. And so now you've got this blue de-identified record of patient 123, and here's the medical information related to it. Now that same patient is going to be interacting with the healthcare system in a number of different ways. Might be seeing different doctors, might be having lab tests, might show up to a pharmacy or multiple pharmacies. And in this case, the encounter at the hospital maybe led to a prescription. The patient then walks into the Walgreens, and a digital record is created there at Walgreens, which is this patient on this day picked up this prescription. And our software can get installed behind the firewall at this pharmacy, tokenize that record, and now you have patient 456 at this location. Now the magic of all of this comes together when Databand has a piece of software that allows for the translation of these different patient tokens at different organizations, so that this translation enables an organization to say, hey, patient 123 that had this diagnosis at this hospital is actually the same patient as patient 456 that went in and picked up this medication. And now you can bring that together to get a more holistic view of this patient and understand, did they actually pick up their prescription? Were they then adherent over time? What was the progression of their lab values? What was the survival rate? And all those types of things. Now, it's really important that this all is secure and HIPAA compliant. So these tokens are made with a one-way cryptographic hash. We do what we call site-specific encryption, which means that patient 123 and 456 are different even for the same patient across organizations, which provides security for the overall ecosystem. And then the last point is that this process, these tokens have been certified by a HIPAA expert. So when Linda talks about de-identification of health data, it's very important to keep in mind that de-identification happens through adherence to safe harbor or through adherence to the expert determination method, where you have an expert assess the risk of re-identification. And we've had a leading expert assess the risk of re-identification and determined that these tokens present negligible risk. And so they are de-identified markers. So that's the upshot of how Databand record linkage works. And with that, I will turn it back over to Linda to talk us through John Snow Labs and how unstructured data can be de-identified and why that's a challenging and important problem.
Thank you, Mark. So in the following section, I am going to introduce John Snow Labs' healthcare NLP capabilities and the features we typically see in a de-identification project. At John Snow Labs, we develop and maintain state-of-the-art NLP models for the healthcare industry. Even during the pandemic, we still kept ourselves very busy and continue to receive industry-recognized awards, including Health Analytics Provider of the Year and Best Healthcare and Life Sciences AI Development Firm of the Year. Spark NLP for healthcare builds on top of the industry's most popular enterprise-grade Spark NLP platform. It consists of a large portfolio of features for extracting meaningful information from medical documents. With over 75 machine learning-based pre-trained models, this powerful package can tackle many of the challenges of de-identifying unstructured text documents and data sets. All right, and to start a de-identification project, it is very important to form a documented plan and consensus between the need to comply with HIPAA and to preserve the demographic information for the study at hand. It is quite a balance, and it does require a very thorough design before you actually start the actual de-identification process. Therefore, each de-identification pipeline can only really be used for the specific use case that is designed for and no more. So the same set of documents will have to go through the same analysis, de-identification planning, and de-identification pipeline, and human verification process for another research project, for another use case. One should not use the same set of de-identified data for multiple use cases and research projects. And here, what I'm showing in this slide is a very common method called masking. Our software leverage Spark OCR, Spark NLP entity extraction, and de-identification masking features to block or what we call mask information on an image within a medical notes or in a structured data set. This process typically does not preserve any information about the field that is being masked. The challenge here is not about extracting one data field, such as age or date of birth, but to understand the text in an unstructured medical notes and mask the information that could possibly be, for example, patient turned 45 last week. It's a written sentence that doesn't state that the age or the date of birth, but as anyone who reads the sentence would know, which the software also needs to be able to identify, is that this patient is 45 and given the medical encounter notes date and mentioning of last week, it could be inferred that to an actual date of birth, which need to be masked as well. So for those type of aspects of de-identification and masking, NLP comes into play, and it's definitely something that needs to be considered when we set up the data pipeline. Another popular de-identification method is obfuscation. And in this case, personal health information, PHI, is identified using NLP, and depending on the planning documentations, one would leverage various de-identification features to replace the real information with somewhat of fake information that is still natural to a reader and to a researcher. The research study might have it might have requirements about preserving the address information to be in a similar social economic area, or preserving gender and age group information, all the unstructured text will have to follow the same obfuscation. So, for example, if the gender is changed for a specific patient due to random obfuscation, all that person's documents will also need to have that same gender, and one NLP would have to pick up all the pronouns and change the pronouns to the appropriate gender as well. So in this slide, we have a few other examples of the de-identification features that's in the Spark NLP for healthcare. ID numbers are often required to be masked or obfuscated. There are several ways listed here for de-identifying numbers. The clients typically need to decide if original ID information needs to be kept. If so, hashing methods is used to create a cryptographic hashing and salting and kept it in a vault that can be connected to the original data. Shifting is a method for changing the dates. When you're doing shifting, there is often a need to make sure that a patient's health records, the sequence of the health record and the duration of the, for example, treatments need to be preserved and consistent in a defined way. So for a typical patient health record, sometimes it could be over 1,000 pages long. All the dates, once the shifting method is applied, it still needs to preserve and be consistent on all the dates for the patient health record to be in the same sequence as before. Generalization is a method used to comply mostly with HIPAA rules that for some rare diseases, there's additional requirements for the information to be even further generalized. Therefore, a client might need to use NLP entity extractions to identify any patients that fall into the category or have such similar rare diseases that wasn't really mentioned in the structured data set, but in any medical document. And if so, then further steps to de-identify the patients and generalize the patients need to be applied. So please visit our website, johnsonlabs.com, Spark NLP in Actions, to see the actual de-identification demos and the simple notebooks that you can already use for your projects. With that, we believe, let's see, Johnson Lab Spark NLP for healthcare and Databand tokenization. There is an opportunity now to study a full patient insights from all of the patient's various health records for any research project you might be interested in doing. And Mark will walk through an example use case.
Yeah, thanks, Linda. So the example use case we have here is we believe, a practical one. So we're imagining a situation where you may have access to or be acquiring data that has unstructured oncology notes. So this could be clinician notes or EHR notes related to oncology visits or tumor size and stage, and that data is in an unstructured form, and the desire is to be able to de-identify that data, structure it, and then be able to link that to additional data about that patient to understand in parallel to the unstructured data what's happening in other diagnoses or other comorbidities, to understand the progression of lab result values, or potentially to link it to mortality data. So as you're looking at this unstructured data and making sense of it, you can then also understand survival rates and things like that. So we think this is a practical example here where the technology that Linda walked through to actually unstructure or de-identify unstructured data can be used in combination with Databand's technology that allows tokenization, so that when a record becomes de-identified, it can still be linked to other data about that patient. So you haven't lost the value to be able to learn more about the patient, but you have made that data de-identified, and therefore it is protected and HIPAA compliant. And Linda, I particularly liked the example that you gave where in the unstructured notes, there may be indirect identifiers about the patient's date of birth, and that kind of illustrates the complexity of de-identifying unstructured data and why powerful technology is needed to be able to do that.
Right, we see that quite common in pretty much every documentation that we've seen.
Exactly, and as part of that technology combined with the certifier together can achieve that de-identified state, and that's why we're excited about John Snow Labs and Databand being used together. We did cook up a imagined workflow here where an actual practitioner that's trying to execute that use case could make this possible. A straightforward diagram here is you're holding the EMR data in an identified environment that can come to Databand, where John Snow Labs technology can be deployed. Databand tokenization can be added to the EMR data. There can be a certification, and then what you're now holding is a de-identified EMR data that is ready for NLP, that is ready for linking, and that can go back, and that asset is now an asset ready for analysis. And then at the very bottom here, we have the additional data sets that if you want to bring in mortality data to be able to link to those unstructured records or lab data, claims data, those would be typical types of data that can then be facilitated through the Databand ecosystem and those list of partners that earlier on in this presentation we showed. So those would be the types of data sources that could be brought in and data could be combined. So this is kind of putting that use case with oncology notes into practice as to how this workflow might actually be realized. So that's kind of the summary here is we're really excited about the combination of these two technologies. We, from Datavant's perspective, see hundreds of organizations de-identifying and working with de-identified health data. It is almost always structured data, and we think that there's huge value locked up in unstructured data, and that's why we're really excited about what we're doing with John Snow Labs to be able to de-identify that data and make it available for linkage and research. And we think there's a ton of patient value that can be provided if we can make that a reality. So we're excited to hear your questions, and hopefully this sparks some interest and sparks some potential projects. And if so, we would love to hear from you. So thank you for your time, and look forward to hearing from you.